What is blockchain? It is a new class of information technology that combines cryptography and distributed ledger, which have existed since many years. Genius mind of Satoshi Nakamoto combined them in new way to create a model where a network of computers collaborate towards maintaining a shared and secure database. To understand blockchain, we need to understand what is cryptography and distributed ledger. So let's say Bob wants to send a secret mail to Alice. There is a risk when Bob sends this letter, somewhere along the way, the letter may be intercepted by somebody other than Alice. And if this letter falls into the wrong hand, the person may read the secret message, write it down, or misuse it, and then continue to pass it to Alice. How can Bob be sure that nobody in the middle can access those information? So Bob will encrypt the message with a key and give it to his friend Alice. So the person in the middle will not be able to understand the message without proper key. So the data is secured that way. Ledger is a kind of database where confirmed transactions are recorded. Unlike age-old ledger method like a book or data stored in a computer or single system. Blockchain can be designed to be decentralized and distributed across a large network of computers. A distributed ledger is a type of database that is shared, replicated, and synchronized among the members of a decentralized network. Then, how it works? Suppose Jack wants to send money to Kim. The transaction is represented online as a block. The block gets distributed across the network. The network verifies transaction is valid. The block is added to the chain in chronological order, reconciling across the network and creating a permanent record. Jack's record of ownership of money moves to Kim. And if you want to make a change in the information of a particular block, you won't rewrite it. Instead, it will be stored in a new block showing X changed to Y at particular date and time called timestamp. So what's so special about blockchain? The way it stores data like no one other, creates trust in the data and removes middleman. First time in the world, people can trust each other and track large peer-to-peer network without centralized network.
Thing exist? How could I send you some bits over the internet that would somehow be interpreted as money? Well, let's think of something we're all familiar with. Email. So how about this? Could this email, which states that it represents one e-money, be used to buy things that cost one e-money? Technically, it could. If enough people started passing these around and accepting them for goods and services, this would be a primitive sort of digital currency. It wouldn't be a very good one, however, in that I could do this. If I had sent you this e-money for, say, a subscription to your weekly blog, thanks for that. I could also send that very same email to my friend Sam, to my cousin Bob, and to my neighbor Mary. Now, all of a sudden, where we started out with just one e-money, we now have 4. Poof! New e-monies were simply created out of thin air. And I could technically do this as many times as I wanted. You can see how this is problematic because it means that our money supply can be rapidly expanded in a completely unaccountable way. If I can create as many new money units as I want, this currency would be what's called infinitely inflatable. Why wouldn't we want unlimited, unpredictable inflation? Let's consider gold for a moment. You know, that really valuable metal shiny rock. What would happen if, say, an asteroid were to hit the Earth that was made of gold and suddenly increased the available supply of gold by 1 trillion? So that there were gold coins lying around everywhere you looked. You wouldn't even be able to step out your front door without kicking over a pile of gold. If gold were as common as pebbles, do you think people would still be willing to trade, say, a car for an ounce of the stuff? I don't think so. In the same way that gold would be devalued if its supply were increased by 1 trillion, same goes for money. Kind of like this. As the supply of money increases, the purchasing power, or what goods and services each individual unit of that money will get you, goes down. As an example, in the United States there used to be something called penny candy. That was because 1 penny would buy you a piece of candy. Now, a lot of people simply throw their pennies away in the trash can because it will no longer buy them anything. If any new monetary system is to be considered worthy of your attention, it's got to not be like that. So, going back to our email example, how could we ensure that anything digital is not infinitely inflatable? Is the digital realm, after all, not the land of copy and paste? Yeah, like that. To prevent the copy and paste problem, inflation, from taking place on our special email money, e-money, what if we tracked every email that was sent on a kind of ledger? Like this. And what if we built a kind of wallet software that read this ledger? So if I tried to send you 2.5 e-monies, my wallet would know that I only have 1. This concept of a digital ledger makes up the entire foundation of digital currency, or as some also call it, cryptocurrency. And that foundation has a name: a blockchain. And now you can be confident that anytime someone drops this fancy word around you, all they're really saying is digital ledger. But if it's a digital ledger, why call it a blockchain? What does that mean? Well, it has to do with how this ledger works. Going back to this concept of a ledger, the most important thing we have to make sure of, to make sure that our monetary supply is open, honest, accountable, auditable, we have to make sure that the numbers are trustworthy. How can we make sure, for example, that I don't do something like this? Wouldn't that be convenient for me? Or how do we make sure that I don't do something like this? Alice never should have crossed me. Well, the answer is that no one gets to change the ledger. They only get to update it. Let's shrink this down. Here's that shrunk down copy of our ledger, and it's time-stamped. If we want to change who owns what, we have to add an update. And on, so that anytime I, you, Bob, Alice, or anyone using the e-money system wants to send some e-money, it gets included in an update. After a bit, you start to see where this digital ledger gets its name. Each update to the ledger is called a block, and the cumulative result of this is a chain. Hence, blockchain. Now you might be thinking to yourself, that seems like a novel way to try to do money, but who gets to make entries into the blockchain? When do they get to make entries into the blockchain? Any old time they want? And why should we trust that people making entries into the blockchain are making accurate entries? Well, my friend, that you would even wonder such a thing tells me that you are clever enough to have a complete understanding of all things blockchain and digital currencies, so why don't you hop on over to episode 2 to find out the answers to your questions. We ended with the questions, who gets to make updated entries into our e-money ledger? When do they get to make them? And why should anybody trust that the updates that they make are accurate? And all of those questions can really be summed up under one heading. Security. What is the security model of a blockchain? To understand that, we first need to conceptualize how a blockchain is run to begin with. And that is via a network, using the internet. The basis of the network is people keeping copies of the blockchain on their computers, and they are connected to one another via the internet. Irina in Russia communicates to Chen in China, communicates to Joe in Australia, communicates to Harry in Hawaii, communicates to Carrie in California, Marie in Mexico, Larry in London, and hundreds or thousands more people across the world, looking something like this. You get the general picture. And the purpose of this network is for all participants with a copy of the blockchain to agree on the state of that blockchain at any given time. For example, a situation like this in which Chen's copy of the blockchain reports that I have 3 e-monies, but Marie's copy reports that I have 47 would cause total chaos and would be of no use to anybody whatsoever. So the state in which all or the majority of the network agrees on the same versions of the blockchain is called consensus. And it is from consensus that a blockchain running network achieves most of its security. So, back to our example of Chen and Marie having conflicting copies of the blockchain. A big no-no, useless for everybody. How do we prevent that from happening and keep consensus about who owns what? I'm going to talk a little bit of computer science to you right now, but don't even worry, it's not a big deal. The mechanism used to maintain consensus on who owns what at any given time is called proof of work. And that just gives us a fancy way of deciding who gets to make an update to the ledger and when. See, the primary goal here is to not have both Chen and Marie broadcasting conflicting versions of our blockchain at the same time. We gotta have one or the other, so which is it gonna be? Chen's version or Marie's version? Using what's called proof of work mining, and I know it's weird that we would use the word mining, but you'll see why in a moment, we can maintain consensus. So back to a stripped down basic version of our network, right? What we don't want is 2 different people with copies of the ledger making an update at the same time. We want only one update to the ledger being made at a time, which everyone else can then take a moment to agree with and incorporate the update into their own copy of the blockchain. This is achieved using specialized computers called miners. Here's what one looks like. Yeah, they really are weird-looking, specialized computers. The computer code looking something like this, that makes our blockchain possible, contains a math problem to be solved. Seems kind of silly when I say it out loud, but I'm not kidding. The computer code has a self-adjusting math problem that these mining machines are built to solve. And the difficulty of the math problem is set to increase as the number of miners on our blockchain network increases. And all this fancy mumbo-jumbo is done to ensure one thing: that only one miner solves the math problem at a time, and that it happens consistently every few minutes. And what happens when a miner solves the math problem? Well, Two things happen, actually. First is that he gets a reward of newly created coins on the blockchain. Yes, I am not kidding. Newly created coins on the blockchain are paid to the miner who solved the math problem as a reward for proving his work. And secondly, he's the one who gets to create the next block. Or in other words, he's the one who gets to publish the next update to the ledger, containing all of the transactions that happened in the last few minutes. And thus does our blockchain, which is a chain of blocks, keep perfect record of every transaction that's made, the time that the block was published, and the total number of coins that exist, including the increase of coins, as the miners were paid in new coins as their reward. As an example, 1,000 coins, then 1,005, then 1,010, and on and on. In this way, our money supply, as recorded on the blockchain, can be considered open and honest. In other words, it's viewable to anybody. This also means that inflation, aka the new money created, is both transparent and predictable. What you need to know now is these accounts. They're not actually tied to your name. That wouldn't work at all. Accounts on a blockchain actually look something more like this. Long alphanumeric addresses, which are actually longer than these, are totally unique, and you can own as many of them as you like. What does this mean? What is this witchcraft? Well, it's based on a form of math called cryptography, actually, and you are totally smart enough to understand it. So hop on over to episode 3 to see how cryptography allows us all to have accounts on a blockchain. What we've discussed thus far is, in our hypothetical digital ledger of e-money, or, hey, our blockchain, the who gets to make updates to it are the miners. You know, those people with the funny, fancy math problem-solving computers. A miner gets to make an update to the ledger when their machine was the first one to have solved the math problem, this being done in a regular and orderly manner. And the reason why we are able to trust these entries into the ledger as being accurate is that the entire history of every unit of e-money is public in the blockchain. Just as an example, imagine that this is a zoomed-in snapshot of 2 consecutive blocks. If this block shows me having more units of e-money than I did in the last block, there has to be a transaction, a record of someone sending me that e-money for this block to be valid. If there isn't, not a valid block. Same would go for your balance. If this block shows you as having 0, and in the last block you had 2.5 units of e-money, again, there must somewhere within this block be a record of a transaction of you sending your 2.5 units of e-money somewhere else. If that didn't actually happen, invalid. And so then you may be wondering, how do people send units of e-money to one another to then be recorded in these blocks in the blockchain? And that takes us to what I told you today's lesson would be about. Cryptography is a form of mathematics that provides the basis for how different accounts on the blockchain interact with one another. And you don't need to understand cryptography, trust me, I don't, to understand how we use it. Remember how I mentioned in the last lesson that on a blockchain, our accounts aren't organized by something like our name, but are rather tracked by cryptographic alphanumeric addresses that look something like this. Psst, the word alphanumeric being a combination of alphabetic letters and numbers. There you go. So if you wanted to, say, pay me some units of e-money to pay me back for taking you out to lunch, I would send you this alphanumeric address, and that would be the address you would send the units of e-money to from your wallet. So our blockchain would show something like your address, unique from mine, having sent 3 units of e-money to my address. And the next block would be published to reflect this transaction. So that leaves us with the question, well, how did you make that transaction? Did you give a phone call to one of the miners and read them off your long alphanumeric address and read them off mine and say, hey, make the update? No. What you did was you broadcasted a message signed by your private key. Rewind. Your address, you know, the one where you receive payments and can then send on payments to others? There's another word for it. It can also be referred to as your public address. And guess what? The only way to move funds out of this address, that is the only way to spend from it, is to know the private key. And private keys are really long and look something like that. And they're stored right within your wallet, so it's not like you have to memorize them or something. And so that's how payments on the eMoney ledger work. You receive funds to your public address, and you can only spend them. That is, you can only move them on the ledger if your wallet software contains the private key. That makes private keys super top secret because anybody who knows the private key for a public address can spend from it. That's why nobody goes around posting their private keys in online forums. It's just not done. So when using your hypothetical eMoney wallet and you want to send Amanda 3 eMonies for covering lunch yesterday, all you as the user do is tell your wallet you want to send 3 eMoney and click send. Easy enough. What your wallet is really doing, however, is creating a signature of your private key that only you know, that broadcasts the amount you want to send and to whom to the entire rest of the network so that they can update their ledgers accordingly. So that whole public address, private key thing, the stuff that's mostly managed by your wallet, that's the cryptography bit. See, I told you it wasn't that hard. And as a little bonus bit of knowledge for you, remember how mining is solving math problems? The math that those mining machines are doing are called hash functions, and they are based on cryptography. Cool, huh? So I have to say right now, congratulations to you, because thus far you already know everything you need to know about a blockchain. First, that it's a digital ledger. Second, that updates to it are mined. And third is that the account system, you know, the sending and receiving bit, as well as the mining system is.
This video explains what blockchain is, why it was developed, how it is being used now, and how it could be used in the future. So let's start off with the first question. What is blockchain? The word block is meant to represent a list of records, while the word chain is meant to describe the linked relationship between these lists of records. So imagine a list of records linked to another list of records. That's basically what the term blockchain describes, linked sets of records. The first known use of blockchain-type technology was in 1991 by Stuart Haber and Scott Stornetta. As our world was evolving toward the digital paradigm, concerns about the accuracy, security, and modifiability of digital records were raised. At this time, use of third-party timestamping services was the only option available that attempted to address these concerns. However, relying on timestamping services that could be susceptible to bribes or security breaches was not ideal. This is because it is imperative to maintain the integrity of digital records by ensuring they cannot be modified, backdated, or forward dated. Otherwise, digital record storage was not likely to be adopted or to succeed. This brings up the next question. Why was blockchain developed? Haber and Stornetta worked on developing a technology that automatically ensured the accuracy, security, and modifiability of digital records using computers and mathematics. they decided to employ use of cryptology to achieve the desired level of privacy and security for digital record keeping. Now, cryptography is the study of secure communications, while cryptology is the term used when you study the application of mathematics to cryptography. In 1992, Haber, Stornetta, and a Mr. Bayer enhanced their cryptographically based blockchain technology by adding the use of hash trees, which are also known as Merkle trees. Let me break this down for you further. First, let's talk about hashes. I'm going to give you an idea of what hashes and hash functions are using Social Security numbers we receive in the United States. Here's a list of some random names that are commonly found in the United States. You can see they all contain different combinations of letters, and each of the names are different lengths. Next, let's imagine a list of unassigned Social Security numbers. You can see all of these Social Security numbers are in a standardized format. Each Social Security number contains a set of 3 whole numbers, a dash, 2 whole numbers, a dash, and 4 whole numbers. Now let's imagine the United States uses a computer function to map each person's name to a unique Social Security number. Regardless of the length of a person's name or the letters used within a person's name, the computer function maps it to the standardized Social Security number. Now, back to hashes. Any computer function that maps arbitrarily sized data, like a list of people's names, to a fixed form of data, like Social Security numbers, is called a hash function. Now, the output of the hash function is a fixed form of data, just like a Social Security number. And this output is commonly known as a hash value, hash code, digest, or simply a hash. Going back to how the word block in blockchain represents a list of records, let's imagine a list of Social Security numbers, or hashes. Imagine that each list of Social Security numbers are stored in blocks, and each block represents a region. And the child block stemming from this represents states, and the child block stemming from that represents cities, and etc. That should give you a very simplistic idea of what a hash tree is. Blocks of hashes stemming from each other that resemble a tree with branches and leaves. The incorporation of the hash tree to Haber, Stornetta, and Bayer's 1992 blockchain-type technology allowed them to securely store larger sets of digital records. On to the next question. How is blockchain being used now? It wasn't until 2008 that the first distributed blockchain was created for use as the underlying technology of Bitcoin, a digital currency. It was made by an anonymous person or group that goes by the pseudonym Satoshi Nakamoto. A common misconception is that Bitcoin is synonymous with blockchain. That, however, is not the case. The blockchain facilitates the secure and private transfer of the digital currency called Bitcoin, as well as posts the transactions to a public ledger to maintain data integrity. Right now, most financial transactions are facilitated and recorded through the use of private parties, such as banks, Visa, MasterCard, and other financial institutions. The Blockchain Foundation allows Bitcoin currency transactions to occur securely and privately, while maintaining the accuracy of the transactions by posting a time-stamped, unmodifiable record of the transaction to a public ledger without the use of a third party. Instead, it uses computers, mathematical algorithms, and cryptology to perform these functions, which allows a direct connection between the Bitcoin users by removing the need for a third party. So again, imagine a list of transactions as a block, and each block is being recorded on a public ledger. So as blocks of transactions are recorded on a running ledger, it creates a chain of blocks, hence the term blockchain. So where is this blockchain, and what does the term public ledger mean? Every transaction between Bitcoin users is processed by a computer that has a Bitcoin processing software on it called Bitcoin Client. This computer is connected to other computers via an online network. So imagine a computer with Bitcoin processing software on it, connected to the internet, which allows the computer to connect to a network of other computers online with Bitcoin processing software. The technical term for each computer that participates in the blockchain network is the word node. So the blockchain network has several nodes, or computers, that it saves all of the recorded blocks of transactions on. This is where the word distributed or decentralized ledger comes from. Since every transaction is saved on every node or computer with Bitcoin client software, on the Bitcoin network, the ledger of all Bitcoin transactions is described as distributed. So if you have a laptop with Bitcoin client software and keep it connected to the internet and the Bitcoin network, you will have the entire Bitcoin transaction ledger saved on your computer. So if your computer breaks, it will not affect the ledger because the same ledger is being distributed on several other computers around the world. So the network cannot be taken down at any specific point. All of these computers process and record blocks of transactions to this public ledger that is saved on all of the nodes connected to the Bitcoin network. The blockchain process creates unique hashes for each transaction, as I mentioned before, that functions to make transactions secure and private. These hashes, as well as timestamps and other unique identifiers, are created for each transaction and recorded on the public ledger. So anyone can go and look at the Bitcoin public ledger and see all of the transactions. When you send or receive Bitcoin, you can identify your transaction by the unique hash that is created, the address of the user it was sent to, which is a randomly generated set of numbers and letters, or the IP address it was sent from. So on to the next question. How can blockchain be used in the future? How else can we utilize blockchain technology besides facilitating digital currency transactions like it does for Bitcoin? There are several applications for blockchain technology in multiple types of industries. Blockchain technology creates transparency, validates and secures records, manages smart contracts, and eliminates middlemen or third parties. Some examples of how blockchain could be used includes recording land record transactions or mortgages, maintaining digital smart contracts like wills or promissory notes, managing digital identities like passports or birth certificates, housing distributed cloud networks to store information like documents or media, and a myriad of other exciting things.
Bitcoin is a digital asset, it's a currency. It is not blockchain. So as long as you understand that, we can keep going. So blockchain is a technology that enables moving of digital assets between two individuals, point A and point B. I once spoke to the financial team of a company and I was like, hey, are you guys interested in using blockchain to move some of your digital assets? Because in the future, the middleman in the finance world is going to be irrelevant. And their response to me was more about Bitcoin and the bad reputation that Bitcoin has because of the popularity of it and how the price fluctuate and X, Y, and Z problems with Bitcoin. But they forgot about the technology of blockchain and how strong that technology is and how it's going to replace a lot of systems that we currently have. Okay, so let's go over one of the problems that blockchain helps solve, and that is money transfer. So let's say that you and your friends are really into the World Cup right now and you guys are making bets with each other. So here's you're A, and your friend is B. So your friend, so you and your friend are like, hey, like, is Nigeria gonna win? You said no, your friend says yes, your friend like, all right, send me $100 because they just won 2 games. So send me my money. And so you're in the US, they're in Nigeria. How are you gonna wire the money? You usually go through a third party, a trusted third party. And what happens is you're like, hey, bank of X, Y, and Z, send my friend $100. And so your bank is gonna check to make sure this is the person that you actually want to send it to, and they're gonna send this guy $100 after they take a fee. And then also this takes like mad time. Let's say 5 days. So this is gonna take extra time. The way that blockchain works is we're gonna make this process cheaper and faster. So blockchain is going to solve this problem without the third party. So we're getting rid of the middleman and we're using open ledgers. Now I'm going to illustrate to you what an open ledger looks like.
Please feel free to pause if I'm going too fast or if I'm missing information.
This is in no way implementation, this is all conceptual. So in this example, we have party A, B, C, and D, and they want to move money amongst each other. So remember you lost that bet and you have to send your friends some money to Nigeria. First, before you send money, before the system even starts, at the beginning, we need to know that A has, let's say, $1,000 in their account. All right, so A has $1,000 in their account before we even start anything. Now A creates a transaction to send B that $100 that you owe him. So, a transaction is added into the ledger showing A moving to B $100. And in the open ledger, these transactions are linked. Now, your friend in Nigeria, B, wants to send that money to their bank. So, B to C. We're sending that $100. Again, we're going to create a transaction here. B to C, $100. And like we said before, this transaction is going to link to the other transaction, creating sort of a chain. And now the credit card service or the bank wants to send that money to their bigger bank, so to speak. This is just an example. But yeah, so C sends to D. C sends to D the $100. And this is linked together. So this open ledger is just a chain of transactions, hence blockchain system. In this process, every transaction is public, very transparent, and everyone can see what's going on. And then everyone can also decide whether or not a transaction is valid or not. So, for example, let's say that party A submits a transaction saying, I want to send, we'll do a different color. So let's say party A says, I want to send $2,000 to party B. To party D. They're like, I want to send $2,000 to party D. We all know that party A only has, $900 in their account right now. So that is automatically, boom, no. So in the blockchain system, it's very open to see what's valid and not valid. In the earlier example, I mentioned how we want to get rid of third parties. In this example, that is a trusted third party, and we want to get rid of that. And this is a centralized example. Blockchain is decentralized. And so the next principle that we're going to go over is distributed ledgers. So blockchain is going to decentralize this process by creating nodes in the system, or in the network, excuse me. And so anyone will be able to hold a ledger. Let me draw it out. So here we are, getting rid of the trusted middleman. Open ledger is going to turn into distributed ledger. So now that it's distributed and everyone can have nodes, I'm going to use these sticky notes. That means that any of these parties can hold a ledger if they want to participate. So here, A has a copy of the ledgers, and the ledgers are basically these chain of transactions that we made. C can hold a copy. Everyone get a copy. B gets a copy. D gets a copy. Everyone, whoever wants to participate, everyone can hold it. But here's where the problem comes from. We want to make sure that everyone is on the same page. We need to make sure that all ledgers have the same information. So how do we do that? Okay, so now we kind of have a general understanding that this is an open system, very transparent, and that there's distributed nodes in the network. And so the question is, how do nodes synchronize? So here's an example that illustrates that concept. We have party B, that broadcasts to the entire system, hey guys, I want to send $100 to party D. But in the blockchain system, this is an unvalidated transaction. It needs to be validated. So this is not going to be put into anyone's ledger yet. Now, who can validate this transaction? Miners. There's this concept called miners. In this example, let's just have A and C be the miners in this party. So we'll call C a miner, and we'll call A a miner. Miners are special nodes that have permission to hold the ledger. And how do they validate this transaction? So what they do is they compete. They compete to be the first one to validate this transaction. And they're rewarded with monetary rewards, money, usually Bitcoin. So how do you get first place in this race to validate this transaction? So first, that's just it. You need to validate this transaction, which is great because this is an open ledger. So you can check whether or not B even has this money in their account. Once you do that, you need to find a special key to take this transaction and lock it into your ledger. That takes a ton of computational power and time, because essentially what you're doing is you're just guessing a ton of random keys until you guess the right one. And once you guess the right key, this transaction goes into the ledger. So let's say C guessed the right answer for this. So then this transaction is locked into the ledger. And now C goes ahead and brags to the network and it shares, hey guys, this is the solution and this is the key. So what happens is once C puts the solution on check, everyone takes it and uses it and it puts it into their own ledgers. So A is going to be like, oh word, C posts the key in the network, so I'm going to go ahead and add it to my ledger. I didn't make the money. I didn't get the Bitcoin for winning this first, but A is going to go ahead and try again for the next transaction that comes. It's basically a race to see who's first. And then once the answer is put into the network, the solution is automatically added to all the ledgers. Okay, so this is mainly an example of what blockchain looks like in the currency state of mind. Just to go over what we learned, we showed how the whole system of blockchain is based off how this whole system is open. There's open ledgers, everything is public and transparent. Blockchain is really sold off the fact that it's transparent, efficient, and the safety and trust aspect could be seen to be more trustworthy than the current manual systems that we have now. So that is